Hello student, I am going to continue from the last video. We are discussing about time series analysis. Many times the line which drawn by least square method is not prove lines of base fit because it is not the present actual, it does not present the actual long term trend. So we distribute time series in subpart and make it following equation like y is equal to a plus bx plus cx square, which is a equation of parabola. So we try to fit the values with some curve, or it is a second degree polynomial function parabola. So we'll try to fit the values or fit the datas with parabola curve, because line will not give you a base fit. That is the point. If this equation is increased up to second degree, then it is called parabola of second degree. If it is increased up to third degree, then it is parabola of third degree. There are three constants a, b and c. It's calculated by following three equations. So equations are this. So using this equation, we need to calculate the values of a, b and c. If we take the deviation from mean year, then all the three equations are like this. So if we deviate from the mean year by some other year, then the change will occur in these equations. So now example is that draw a parabola of second degree from the following data, that is year 1992, 1993, 1994, 1995 or 1996. Then production 5, 7, 4, 9, 10. It is 5,000, 7,000 like that. That is point here. And then year is 1990, main data will be drawn here. Production is this much. Year is this much. So deviation from the middle is that 1984. So from the middle, that is -2, -1, 0. This is 1, +1, this is +2. And again, so x into y, this is the y. So x into y is -10, x into y is -7, x into this 0, 9, 20. So here again you can see here summation of y, which will be required for this equation. Summation of y is 35 if you sum out these values. Then again summation of x equal to 0, because this is 0, this is -2, this 1 is 1, 0, +1, +2, 0. Then xy, summation of xy is 12, x squared, that is x square of this x, that is the values, and summation is 10. Summation is 10, and x squared y is this one. All these values are required for this equation, okay, to find out the values of a, b and c. So in that way we have tried to find out x squared, y, x cube and x4. So at last we need to find these values. So to find these values, we need to find the values of a, b, c. So we take deviation from middle layer, so the equations are now as follows. So we are taking the deviation from middle layer, so the equation as follows. This one. Now put the values of this is like this. So if you put these three equations, it will be like these three equations. So from equation 2 we get b equal to 12 by 10, this 1.2, and equation 2 is multiplied by 2 and multiplied from 3, then we will get the values of c. Now putting the values of c in the equation 1, we will get the values of a. So after getting the values of a, b, c as 6.34, 1.2 and 0.43, we can find the values here by putting the values of x and x squared. Also, if you go for like third degree, then you need to go for x cube, but you need to go for also, you need to find this value d. Then the equation will be this one for normal equations, because you need to find the value d also. So in that way the parabolic degree will be created. So this is the method to find the parabolic curve to fit the values. So this will fit the values of this one to find the trend. Again, there are various methods of seasonal variation like seasonal average method, linked relative method, ratio to trend method, and ratio to moving average method. Here you can see seasonal average equal to total of seasonal values divided by number of years. Again, general average is total number of seasonal averages, and number of seasons. Again, third one is seasonal index, that is seasonal average divided by general average, that is seasonal index, and that is general average means total of seasonal averages and number of seasons, and seasonal average is total of seasonal values and number of years. From the following data, calculate quarterly seasonal indices assuming the absence of any type of trend. So there is 4 values in this is 4 seasons in 1 year. So for all 4 seasons there are values for these years. So we need to find that seasonal indices like this, seasonal indexes or indices assuming the absence of any type of trend. So here you can see total of this one is this one, second season is this one, third season is this one, fourth season is this one. So total is this. So average of this one is this 125.75 because this is divided by 5 and this is divided by 5 is 119 like that, and total average is 497.75, and then quarterly turnover season indices is 124.44 or equal to 100 that has been taken, quarterly turnover season indices. So here general average is 497.75 equal to 124.4 divided by 4 equal to this one divided by 4 by 124. So quarterly seasonal inflation index is 1. Suppose for one value is 125.75, thereby 124.44 into 100. So as on we calculate the other seasonal indices. So something is wrong in here actually. So you need to find is this. So second one is linked relative method. In this method the following steps are taken for calculating seasonal variation indices. We calculate linked relatives of seasonal figures, like linked relative equal to current season figures into 100 divided by previous season's figure. So that is linked relative, means there is a link between current and previous seasons. So we calculate the average of linked relative for each seasons. So convert this average into same relatives on the basis of the first seasons. Then calculate the same relatives of the first season on the basis of the last seasons. There will be some difference between the same relatives of the first seasons and the same relatives calculated by the previous method. This difference will give to effect of long-term changes. For correction, the same relatives of the first season calculated by first method is deducted from the same relative calculated by second method. Then express the corrected same relatives as percentage of their wages. So try to go through this process by taking the same values here. So try to find out the thing. Again, if you find a difficulty, please let me know. And this is ratio to trend method. That this method based on multiple model of time series. In it we use the following steps. We calculate a trend value for various time duration with the help of least square method. Then we express the all original data as the percentage of trend on the basis of following formula, like original data divided by trend value into 100. Then rest of the process are same as moving average method. Another one is method of cyclical variations like residual method, reference cycle analysis method, direct method, harmonic analysis method. So we'll try to go through them in the next video. Okay, so please try to go through this the last one with the same data and try to find out what you can find and what you can calculate. If not, please let me know. I'll try to resolve that thing over Google Meet. So till then, thank you.